Good afternoon, everyone. Thank you for finding our room all the way back here in the back. I was looking the whole time like, am I going to make it on time? A little scary. We're here to talk to you about data fabrics. Not the data fabric you heard earlier, but the data fabric that Gardner's talking about, the overlay that sits across your data lakes and data warehouses, and really a neat way to use graph and something we've had some fun building out for a couple of different clients. So let me get started. My name is Joe Hilger. I'm the CEO and one of the COO and co-founder of Enterprise Knowledge, which is a knowledge management consultancy based right outside of Washington, D.C. And we've been doing graph projects for, 5, 6, 7 years now.
Everybody. My name is Lulit Tesfaye. I am a partner in Enterprise Knowledge, also directly oversee our graph solutions implementation strategy design. I'm fortunate enough to work with a team of brilliant ontologists, graph engineers, data scientists, and very excited to be amongst this crowd that really gets this space, and looking forward to sharing our experience with you today. So thank you for joining us. I know it's been a long day and it's an end of day, so hopefully we'll make it exciting for you.
So real quick about EK, or Enterprise Knowledge, I don't want to spend too much time on this. We are actually the world's largest dedicated knowledge management consultancy. If you want to know how niche knowledge management is, we've got 80 consultants, but we get calls around the world. And what it is helping companies find information and reuse it in a better way. Sound like a common problem? How many here work for a big company and can't find what you need most of your day? All right, good. Oh, we've seen the Neo4j crowd doing it too. So this is what we help fix. PricewaterhouseCoopers, General Motors, European Central Bank, they call us and say, help us communicate better internally and help us find what we need. So a bit more about us. This is a big problem. It's as a result of kind of solving this problem, particularly our graph work, which is what Lulit leads. We've made the Inc. 5000 list of fastest growing companies in the United States 4 years running. And actually we'll make it again this year. So a lot of people are having these problems. A lot of people are having graph problems. Some of that's probably why you're here. And so we get to help people solve their problems. I won't spend more time here. Let's talk about what we're doing. So how many people have heard about data fabrics? Now, not what Emil talked about this morning about like almost clustering, but the classic data fabric problem of overlaying your data sets and your data lakes. Awesome. That's what we're here to talk about. And let's start, before we define it and talk about what it is, I want to talk about why it is. So, if we go back in time, everyone was building their data warehouses, right? And what they found is, creating my data warehouse, this is the way to do it. We put it all in one place, and then it became a nightmare to standardize your data. It became a nightmare to make it work. And all the processing, remember the days of processing to get your answers, those batch processes you had to run. So then technology got better, as it does, and we started creating data lakes. And everyone's like, well, that's the answer, right? A data lake. It's everything all in one place, and now we can process it faster. It's still heterogeneous data. It's not consistent, it's different. So what we've slowly started to realize, and this is how we all grow, is that the real problem isn't the technology, right? Technology does amazing things. The demo we saw this morning, how fast Neo4j was going through billions of records, right? Technology can do that when set up the correct way. So technology isn't the limiter. The problem here is, how do you take fragmented data in an inconsistent structure that doesn't align with the way people think, right? That's another topic you hear here in the graph world, the way people think. And align it so that you can start to work with it and you can create consistency and create a pattern that people can follow and understand. So that data lake with tens of thousands of data sets, maybe hundreds of thousands of data sets, can be usable by almost anyone that gets involved there. So that's really the core problem. And when we think about it, solving that problem, again, isn't just technology. Now, technology is key. Graphs are what makes this happen. But what really helps you solve that problem is modeling things the right way. So a lot of what we're going to talk about is how do you build the models on top of your graph to make this work and to make this work at scale. So let's go back and talk about a definition of data fabric. And 2 weeks ago, I was speaking at the Data Summit. And I think I heard 8 different definitions of data fabric. Right? So I'd like to at least put one out here so we have a common theme. And I'm going to read the start of this and then I'm going to talk about it. A data fabric is a logical, emphasis on logical, architectural approach that serves as a connection between the data layer and the knowledge layer. The knowledge layer is all of us and how we speak and think about things, right? So how do we take this data that's typically captured in a transactional format by systems that were designed to capture data, but not to report on it and present it, and get it organized in a way that the entire organization, and you can, not just your data nerds, your data scientists, but what about those people that are asking the simple questions that are business leaders? How do we get data structured in a way that's usable? And so a data fabric is about pulling that information together and making it work in that fashion. So it becomes that layer that sits between the data and the people to get it to align and fit. So how do you build a data fabric? What are the pieces that tie it together? The first is metadata, right? We all live in a graph world. Metadata is huge, right? That's the descriptive data that defines what we have, right? So I'm looking at this data element or this data set. What is it? What's its purpose? Why am I using it? Second is taxonomies and ontologies. How many people know what a taxonomy is in this room? Okay, we've got a few, right? So a taxonomy is a structured hierarchical list that describes things. It's a way to categorize it. Most of your taxonomists are library scientists. Think of how you organize things in the library. Imagine if you've got data sets from different places, what if you have different ways of describing them? How do you make them consistent and similar? Actually, a taxonomy helps make that happen. So you have some work to say, what are the topics, right? When I was doing work at GSA, General Services Administration, they needed a taxonomy because when they were talking about their buildings all over the country that they were managing, what they couldn't do consistently is say where it was located. Some people would talk about the region, some would talk about some of the state or the city. So a taxonomy gave them a consistent way to call it out so they could say, X in this data set is similar to Y in this data set. The ontology becomes the description of how they align together, and we're going to get into that a lot more here. It's actually really the heart of this. And when you've put together your taxonomy with your categories, your ontology with your description of how things associate together, that's the basis of your knowledge graph. For those of us from the old relational database world where you had your, ERD diagram, right? That ontology becomes how you describe the structure of your knowledge graph. And then the next pieces that you have to figure out is how do you connect and integrate this stuff together, right? It's not enough to just say, I've got my ontology now, I've got data everywhere. And I think we saw some great examples where people were pulling data, right? Again, in our kickoff, where we saw people pulling data from different sources. Well, often we have a team of Python developers saying, let me get this from here, and pull it together. So those connections and integrations are where you take your disparate data sources that exist all over the enterprise and pull them into the graph in the format that the graph wants. And then lastly, and this is often, it's funny, we used to think this was the big piece of work, and it isn't always. Once you've got that structure, now how do you overlay it? What are the applications that show it? This could be Tableau. This could be a custom development. This could be Link Curious. This could be some of the, Graphable. This could be Bloom. These are tools that helps you look at and analyze your data in a way that's helpful. So we start with the metadata and build our way all the way up to the end state where the user is able to look for and query information in a way that aligns with how they think about it. So let's take another look at this architecturally. You start with your data sources. Content management systems. Everything does not have to be limited to structured data. When I was working with a couple major insurance companies, they cared about their data sets, but at the same time, they also wanted to know what's written up in the claims. How do I pull information out of that and work with that? How do I take key terms that tell me more about this and pull it together? You have your data lake or your data warehouse. Those aren't the same thing, obviously, but that's where your data sets are. So we've got unstructured and structured. But then don't be limited to that which is within your four walls, right? A lot of our clients talk about their subscriptions for services. So when we were doing consulting for PricewaterhouseCoopers US tax, right? 8,000 consultants around the country, lawyers or auditors, right? As you know, very detail-oriented people. What they cared about is go get me the stuff from Thomson Reuters. Go get me the stuff from tax analysts and bring that in, because that's data and information that matters. So you never want to limit your world to your four walls. And then lastly, there can be other external sources, open data projects. The federal government is pushing a lot of that out there. We always see Wikidata, other places to start pull information in that allows you to round out and create structured answers that come not just, don't give me a SQL query that gives me the sum total of a column in a database that I processed the other night, right? Everyone in the world can do that. The leading companies are taking information across all these sources and pulling it together. Well, how do you do that? Now there's that middle layer. This is the data fabric. Typically we take a data catalog, right? Those actually have gotten very hot now. You know, the Elations, the Calibras, the data.worlds out there. They're good at capturing metadata, right? So if you want, you can make your graph be the data catalog, and that's a great answer. But if you already have a data catalog, if you've taken that effort to manage the metadata that describes your data sets, that tells you about them, right? The descriptiveness about them, then you can pull that into the graph, and now all of a sudden you have power. And as you're starting to associate things, and we'll talk about this later, as we start to associate things together, the graph can pull it together from all these places. So again, you can have your graph own everything, but you don't have to. In a classic data fabric, and this was neat, when Gartner first came out with this, they said we need a map that maps all this information together. And they didn't know at the time that they were asking for a graph, but then people built it. And now you go to these conferences and everyone goes, who's got graph? Because that's your data fabric. Well, graph is the tool that enables your data fabric. But it really is the perfect tool for it. And the fun thing is, when we talk about the use cases, do you all remember the use cases Emil showed? Who saw data fabric on the list? No, you didn't, because it wasn't on it. Remember he said there's more use cases over and over? This is one of the hottest things in the data space, and we didn't even talk about it. Yet you've got probably 4 presentations here that are all going to be talking about it, and we've got 4 or 5 different clients that we're doing this with at scale. Real big, like 350 petabyte data lakes. So then you see the top. This is how you search for it. You know, it's interesting in the data world, there's a trend towards getting away from the old school report building tools and the idea of search, right? So ask search questions and get data results back. Really, really neat and interesting. A lot of people think that's going to enable the democratization of data. Anyone can access and get information. And then the next step beyond that is, let's go ask Siri or ask Google, right? Let me ask the question and I can pull out and get all this information. You do that, you can't do that without a graph. In fact, I had a funny story. We were doing work for a very large oil company, and we were competing to solve this question and answer data solution. And there were some companies that had canned products, and we did three iterations. It was like a sprint, and it was going to be a competition. Sprint 1, we got crushed. We spent all our time building the data model, right? Sprint 2, they started asking more questions. All of a sudden, we could do everything because the model told us how to map things. And by Sprint 3, the other vendors had fallen off. They couldn't adjust to changes. Tweaking the model, we're off and running. The other thing is, think about how your information is stored in Neo4j. It's talking about such and such is related to, X is related to Y. Isn't that how we speak? Subject, predicate, object? Since we're storing information in a way that aligns with the way people speak, doesn't that quickly make it the best answer for responding to spoken questions? Or English language, what we call natural language query, NLQ example. So really, as you start to see the modernization of not just how we look at data and data platforms, but how we access it, graph is going to be the key convention for doing all of that. And this is kind of an example of what that looks like. So when do you need a data fabric? And I almost want to say you always do, but you don't, right? If you have data that's very consistent, one set, you're not trying to link it across multiple areas, then you're probably fine, right? A very homogeneous data set is going to work for you. But if you have highly interrelated data, and Emil talked about a great story about how now all of a sudden we're building one data set, and then we're adding another use case and another use case, right? Because we're realizing everything's interrelated. I've got data about my customer. I've got data about my product, right? Maybe I thought of them as separate things, but aren't they tied together? Wouldn't it be nice if they were tied together, right? So how do we do that? Business context. This is where we understand what we're looking at. So instead of cust_NO, right? What if it was customer identifier? What if we knew what it was? What if we knew this was about a person, right? This is how you do things in Neo4j. It's funny, when I talk to the data crowd about this, they look at me like, wow, how can you do that? Everyone here that knows Neo4j is going, well, yeah, that's kind of what it does, right? So this is when you want this. Help me understand not just what I'm trying to work with, but what it is and how I understand it. Frequent changes. The great thing about graph over relational databases, besides that it's better at relationships, which is kind of amusing, the best thing about it is it changes easily. Oh, we've got a new relationship. Let's add a new tie. Let's tie these together and pull them forward. And then really important that we've seen is we talk about, has anyone heard the term explainable AI? Okay. If you learn nothing else from this talk, it's one of the most important things in the AI space right now and something you all should be aware of. So there's a lot of people that are using machine learning to do black box. Here's your question, here's your answer, right? In fact, IBM had won Jeopardy with a tool like that. A lot of people that have implemented that, what they find along the way is it's a great tool, but what if it gives me the wrong answer? What if I don't like the answer? What do I do? Well, with explainable AI, with a graph, you can map back to how you got to that answer, and you can qualify it. This creates trust, and it creates the ability to tune and improve your answers. So very important as to what you do. So when you're looking, do I need this? This is the data. This is kind of the rule set that you want to consider. So next, Lulit's going to talk about actually how you build this. Quick question? Yeah.
So I'm just curious if you're seeing any integrations with like blockchain technologies and enterprise blockchains with smart contracts governing the data, feeding into the data fabric?
We actually have, so the use case we're going to talk about after she's done immediately talks about creating consistency of data. So if you can hold on a minute, I can talk about that.
Okay, so we are going to get into the specific use cases. I know the title was one use case, but we snuck in another one because we thought it was important to share and touches across multiple industries. But before we get into that, we want to spend a little bit of time talking about how do you scale a graph solution and how do you get it into an enterprise data fabric state. And as I get started here, one thing I thought would be helpful to share would be where our clients are in their journey when it comes to enterprise graph applications. So for simplicity, I was thinking about it as Joe was speaking. I would bucket them in like 4 categories. These are our active clients right now. Those that are pre-graph that are more focused, either they don't have the use case, as Joe talked about, when you need a graph or not, or are just in early stages of their maturity, they're not even thinking about that. And then there are, second tier are those that are thinking about it and building the foundations for it, those that are doing content cleanup, content strategy, their data management, knowledge management strategy, building taxonomies and ontologies as the foundations. And then we have in the third bucket, those organizations that are prototyping or piloting solutions, and those are those that are downloading the 250K downloads that Neo4j is getting, those people who are actually experimenting and prototyping with Graph. And then last are those that are scaled implementations, and we'll share a couple of those user stories today that we've selected for this. But as you could imagine, a huge percentage of, or a majority of the organizations that we work with are within the middle tier. In the past 2 years, I would say moving closer to the prototyping and piloting phase. And then we have that less than 10%, maybe not even on the enterprise, that have reached the maturity to enterprise scale. And I want to share that because if maybe the next 2 or 3 Graph Connects later, if I was to tell this story, I think the data is going to shift. Because we're seeing a lot of these organizations that are doing the prototyping foundations and piloting will be in a position to scale, especially with what we are hearing with the products that are really maturing. And it's really exciting to see Neo4j moving from the graph database that we knew 10 years ago to the platform. And I will talk a little bit about that architecture. So with that in mind, why I'm making this statement is we have identified, we've been working through, with these organizations, taking them to the enterprise, the scaling process. It's not easy, it's an investment, but we see common themes across the board, and these are those 5 common themes that I want to share. There are a lot more implementation components with infrastructure, security. I think we know all that, but I think what's important for this conversation is what are the 5 things that just keep appearing over and over again that we've been working throughout. So the biggest hurdle is knowing where to start. For those, 2-3 years ago, the questions we were getting were, search doesn't work. We have a data analytics problem. Fast forward now, organizations are coming to us. Joe mentioned there are data lakes. I think somebody was talking about yesterday at the Partner Summit about the frozen data lake situation that's happening. Even beyond that, now organizations are coming to us and say, I need to know how my data is related. Right? They're asking direct graph-related questions. So the traditional common challenges of knowledge management and data management still persist, even to this day. So that problem or use case, defining that problem or the use case is the biggest part of this. And if we are not focusing early on, especially knowing that a lot of organizations are still testing it out and are figuring out if this is the right solution for them, finding the best right use case is the most important one. And I have some examples coming after this. The second piece, Joe touched on this, is the metadata. This shifts the focus from the data itself, right, to that descriptive layer, that abstraction layer that would allow us to connect the aboutness of data and to know what that data is about, which goes directly into the data model. And here we're talking about, there are multiple types of schemas, but we're talking about knowledge graphs and ontologies and relationships, where relationships and metadata are first-class citizen. And then a big part of this is number 4, which is, I think there was a question about this. How do you apply this to your data? How do you connect it to your data? And if you ask me across all of this, 2 to 4 is where we really spend most of our time on these engagements. Modeling and then data, the cleansing and the application of the data. And we actually, I think we hope it's memorable. I have these 4 C's that I call out every time. If you build a data fabric or a knowledge graph, it needs to do 4 things. The first C is it needs to address for the data complexity and cleanup, because I think we all know most of the work is cleaning that garbage, right? The second piece, yeah, sorry, go ahead. Okay, so the second C is about collaboration, creating that collaborative model between those people who are creating the data and applying, and building the software and the solutions. And the one example here is, if metadata, we're using metadata, we need to allow people to apply metadata at the point of creation of the data, or automate the application of it through auto tagging or auto classification. So creating that collaboration between data creation and data management and data governance. The third C is connectivity. I think Joe talked about that, being able to show how data is connected. That's our data model, the ontology model. And then the fourth piece is context. We've worked with, I think, 4 or 5 financial institutions at this point. There are core similarities, and they have some standards with the FIBO ontology model, but every institution's graph model is different. It has its own flavor. The way they describe product for one company is a service for another. So when you build that data model, that ontology model, the context of the organization matters. So these 4 C's are really the important factors that if you see it as a checklist, like a graph model or a data fabric model should address. You had a question?
My question is more about the problem or the use case. What level we really thinking about like the problem or use case? I totally understand when we design something, the use case is always it's important. But it's important when we talk about the atomic level implementation. It's something we need to talk about the fabric or layer or lake. I want to get more rewards with my investment. How do we maximize that?
I love that question. So that goes into my next slide. That's actually a perfect question. So that's the where to start problem, the barrier to entry, one of the biggest ones. And that's to kind of categorize the use cases. But for summarize, there are 2 types of use cases that we get. And use case is very loosely defined, right? What is one use case for one of our clients, which is help us build a data model for the environmental sustainability group, an ontology model. That's a project, that's an initiative, but it's also a use case. But when we're talking about a use case, there's the business use case that you want to prove, and then there's the technical use case. A business use case goes something like, help me answer a question across all my data, who is my most profitable customer, or who is my most profitable plant in the oil and gas scenario. That's a business question. A technical question is, how do we integrate these 4 or 5 systems to be able to do exploratory analysis or be able to do some sort of analytics? So an ideal use case would allow you to answer both. However, when you're starting small and you want to do something very quickly, we have what we call our use case card, where you would be able to identify through a checklist. Do we have a group who can support this? Show this quickly. Would we be able to answer this with an export data to show the proof of value first? And then if we can we integrate with one system to demonstrate the technical side of things? What you don't want to do on your first use case is pick the most complex challenge. So for a financial regulator that we are working with, initially we started the prototype in 2018, I think. The initial prototype was 2018, and the question they were looking to answer, they have a lot of economists and data analysts that are touching the same spreadsheet 5 times and creating their own versions of it, to answer, to regulate a financial institution, for instance. And if we started, for that use case, we started with public data that the financial institutions are required to submit, because that gives that lower, what we're looking to prove is that by building relationships, we would be able to answer the question. But we can't really, if we were to pick the actual data that they submit that is protected under the 4 walls of the organization, then that problem would have, that whole project would have stalled. But this allowed us to show the use case very quickly. You wanted to add something?
I want to throw one in because this was a fun one. We had a customer come to us and said, we need to be pushed information. So we don't know what we don't know. We need to be told it's there. And that was the start of their use case. What we actually built for them was a tool when you would schedule a meeting, you could invite the brain, they called it the brain, to the meeting. The brain read the meeting, looked up all the information and content that was out there and said, based on the topics I'm seeing in this meeting, here's some recommended pre-readings so that when you're at the meeting, you're successful, right? That was a big deal. And then we took that and built like 10 other features off of it and grew out just the way classic Neo4j does it, right? But it started with, I have people going into meetings, they're unprepared, and they don't know what they don't know. News comes out a day or two before, this is super critical, we don't know. This is a big deal and it's embarrassing. So that was a use case that started the train rolling, and then it just kept going.
Yeah. And I would say, just from looking around, the most successful use cases that go to scale are those that are within the areas of the business that are the most visible. So for the example that Joe is going to share about our case study, that's the customer platform, because it's a financial institution, and the first thing that they want to address questions for are their customers. So when client leads come to us or client come to us and ask, usually it's coming from a data group or champions pocket of the organization. The first question we are going to ask, and we have a long list of a checklist that we walk them through, is who are the users? Who's going to be touching this first? How would it be visualized? And then being able to show that visual clickable prototype or proof of concept very quickly, which goes into the phased approach that we leverage because our attention spans are going pretty much. So it's very important to be able to show something very quickly, and this is something I think that has time and time again made us successful for a lot of our projects. We start with a quick pilot that we can do within a matter of 8 to 10 or 12 weeks. Depending on the environment. We have what we call our Knowledge Graph Accelerator, a package that we have that we've tried, we've delivered time and time again and have a really good conversion rate on that. And what we do with that is what I talked about, validating the technical and the business use case, but also at this point, there's a lot of questions about, is this even the right solution for us? So being able to show quickly what a solution look like and what question is going to answer and create that alignment within the organization. Integration may not be the prime focus at this stage. That's when we talk about the MVP. So moving into the MVP, which is also time boxed into very short sprints where you would be able to show something. Here the focus is about how does this work within your infrastructure? What use cases would it support? And sometimes it's not for the whole whole organization. Sometimes it's for some departments. But this is when we start talking about, now you see the value, let's see how it expands. So expand the data sources, expand the use cases, expand the users, and then create that repeatable process so you can go into scale. And as we're getting into scale, we're talking about the team that will need to support this. A lot of organizations may not have the skill sets in-house. Some do, or have a workforce that could be trained on that. So getting them ready in a position to scale it and to support it is part of that. Examples of artifacts that come out of all these across these engagements. The use case definition card that I was talking about, there's a little snippet of that, but we do have a use case card where we walk organizations through the specifics of like the checklist of what a successful use case would look like. We have the semantic model, the data model that comes out of that, the ontology model, which gets into a graph. Solution architecture evolves throughout. The solution architecture we build for the prototype is not the same as the one we build for the MVP, but that is what helps us develop the MVP architecture and then the scale architecture. So that is very important that it evolves with the use cases as well. And then the consuming applications, Joe touched on that. It is very important to visualize a graph for people, not the way we talk about it in Bloom, but in a way that they ask a natural language question and they get an answer. And it's magic, but it's graph behind it. So the last piece I would call out here is it's important to note, with the context and connectivity that we're talking about, this is no longer an IT and data team problem. Domain knowledge owners, data creators, the business owners become the core part of the success of this. So we have what we call our executive planning guide that we give all organizations that we work with. Here are the people in the groups and the different people that need to be involved for this to be successful or to scale right from the beginning. Even if we're prototyping, it is important for the organization to plan for all these pieces of the organization that we would need to collaborate to deliver this. So with that, I'll pass it over to Joe to walk us through the case study.
Thank you. There you go. So you talked about data consistency, right? Garbage in, garbage out. That's use case number one. So thank you. I owe you. We'll do that later. I'll buy you a drink tonight. Okay. So working with one of the largest financial organizations in the world, they had a 350 petabyte data lake. You can imagine how much data. 10 plus business units all trying to use that data. So they had their products, they had their customers, they had different types of transactions, they had fees, non-cash transactions, et cetera. In fact, when our team started to engage with them, they had to do a week-long training to learn the business so they could help model this with the business. Even though we do that regularly, without it, this was so complex, this is what they needed. But what they realized is if they could create a model that described, here's a product, and these are the attributes that I care about a product. Here's a customer, here's what I know about them and how they relate together, right? And they said this model was the standard by what everything does and how it works. Then what they could do is enforce that as data came in that it met that requirement. So this is the easiest example. I almost hate giving it because it's you go, oh, well, that's simple, right? But imagine other areas of this. So one of the attributes that we know about either a person or a transaction is that it's in a state, right? Well, and it's inside of a country because they're international. Well, so we define that a transaction, that's one of our entities in the graph, has a property that's a state. Well, guess what? They have 10 different ways of calling it that in all the different data sets. So what happens is, as people are checking in data sets to this data lake, it asks, what's this field for? And when you say, oh, it's a state, now we've done the mapping. And then it goes, but wait, state has requirements. It needs to be 2 letters, it needs to follow this, et cetera. So what we've done is the graph doesn't only define the model and the attributes in a way that people think about it, that we're all comfortable with, it also defines the rules about how those have to be. So data sets that don't match that can be called out, right? So a customer number, or maybe there's 3 different types of customer numbers, and I know they map together, and I know this is how they work, right? So it's state is easy, country is easy, but there's more you do there. So really what we're using, not only is the fabric giving you a consistent, easy way to ask for stuff because now everything's mapped, it's also enforcing that garbage in, garbage out. When you actually, it's funny, we were meeting with them as it was about to go live with the first bit, and they were like, oh my gosh, I don't think anyone realizes we just built an ontology that's going to tell them how to manufacture their data. And there's 10 business units across the entire enterprise that are going to go, what just happened to me? You put rules in place I didn't know. But at the end of the day, now all of a sudden, one product can see a single view of their customer across another product. Now all of a sudden, this organization has 7 customer numbers like we all do, but they know it's one person, and they know what products they have, and they can now be smarter about what they do. And they've enforced consistency through a simple data model, through a graph, all the way through it. Now, I make that sound simple. There's a lot of governance, and this is where Lulit talked about this. Build that business case. Make sure it's important. But this is enterprise, and they're doing this for a massive structure. So we start with standards. That's defined in the ontology and in the data model as we talk about it. Then, as we put it into production, as you're moving things to production, you register your data. And it goes against the model to make sure that it's mapped and correct. And then we validate and enforce it. And then now, at this point, we have enough consistency or enough understanding of our data across our data sets that we can really start to work with it, and we no longer care which business unit originated it. And we are almost at time. I want to give Lulit a quick chance to do use case 2.
We don't have to spend a lot of time on this. We included it so it's shared. But this is a use case for a bioengineering firm that was looking to extract data across 4 legacy systems and across 5 departments that have their own processes. So they create a cell culture in one department and in one system. By the time it gets to the engineering group and it's forming into a graph, the challenge that, forming into a drug, the challenge that they were having is that traceability, lineage, not even understanding where this came from, because one cell culture could be different things. So being able to understand and track that across the board, and the biggest challenge being getting data out of these legacy systems. So they heavily relied on manual processes. So we built them an ontology design model that would allow them to standardize their data across the board based on their multiple standards in the bioengineering space, but leveraging those and then augmenting that with their internal context. And there's more details here, but one thing I want to share, this is my favorite example. It's been obfuscated, of course. It doesn't have any of their architecture. It doesn't have any of their stuff. But the key thing here is, and I said this earlier, with Neo4j going into the platform space, to get to that data fabric space, these are the components, the core things that we need. And there are multiple logos you can put here. But there is not one single solution or one application that answers all these questions. And at the end of the day, we're really not creating, we're really connecting the pieces. We're not creating a ton of new things, but more helping them connect the pieces. So as you would imagine, the biggest investment in these types of efforts is spent on that connection layer. Getting the data out, cleaning up the data, and making that connection. So what I would love to leave you with is these considerations getting into from the pilot space to scale. The first thing is, I think the focus should be more on federating cultures, the culture, that mindset, than the actual technology. Because technology is, as we've seen, it's maturing and improving and is there to support. The biggest challenge is getting the organization ready for that mind frame of federating their data. The second aspect of this is, even if they're not ready to go through a full implementation, helping them plan and helping them ask the right questions on what kind of resources that they would need. And we've talked about that, which is that path to production and what that would look like. And then lastly, what are the core pieces that they would need, the things that we talked about, the 4 C's and the foundations that they would need to have in place. And even if we're showing something within 8 to 12 weeks to 10 weeks, in order to show something meaningful at the enterprise level, looking across our projects, it takes about 6 to 7 months. And that's if the organization is quick enough. Also, you don't have, there are a lot of security onboarding processes and all that good stuff that we go through. But with that aside, on average, it takes about that much time for this to be at the enterprise level. So it's important to set that expectation from the get-go. Yeah, go ahead. Yeah, absolutely.
Does your solution require enforcement at user level? For example, if users are not following the standards, making mistakes, will technology take care of it?
Oh, you want to take it? Go ahead.
So the example we gave earlier, that's actually what it was doing. It was confirming that. So I know we're over. If our other speakers here, I feel bad. Maybe we can go outside and take questions from people. But thank you all for coming.
Thank you very much.